Welcome to Finlex Insight, your hub for smart finance and business knowledge. Simple, practical, and powerful insights.
International pressure is escalating on global supply chains to adhere to net zero and global methane reduction pledges. The primary source of this greenhouse gas externality is the scale of agricultural production in India. This chart breaks down global man-made methane emissions. Rice cultivation accounts for nearly 15% of the global total. Its severity comes down to heat-trapping mechanics. Over 20 years, methane is 80 times more potent than carbon dioxide. Historically, this agricultural reality was priced as an unsolvable environmental tax and a permanent regulatory liability for the state. Bangalore is currently emerging as the hub where agricultural technology intersects with climate finance. Mitti Labs operates out of this hub. Their core objective is engineering a system to convert decentralized methane liabilities into centralized multi-million-dollar carbon assets. This creates a link between the physical reality of rural farming and the corporate reality of a tradable asset on a Fortune 500 balance sheet. The central tension here is economic. Incentivizing a smallhold farmer to alter a 1,000-year-old agricultural practice requires a financial reason to do so. To understand the solution, we will deconstruct the specific measurement, reporting, and verification tech stack, the legal architecture, and the financial flow making this possible. Solving agricultural emissions requires complex cryptographic and legal engineering. This flowchart illustrates the asset creation model. A carbon credit represents cryptographically verified proof of the absence of methane. To get there, we trace methane to its origin. Traditional farming relies on flooding, creating a completely oxygen-deprived environment in the soil. These flooded conditions trigger methanogenesis. Anaerobic bacteria in the root systems actively generate and release methane gas into the atmosphere. The physical intervention designed to stop this process is alternate wetting and drying, or AWD. The mechanics are straightforward. By systematically drying the fields at specific intervals, oxygen returns, the anaerobic cycle is broken, and methane output drops. Economic incentives are the primary barrier to AWD adoption. If a decentralized network of farmers claims to have altered flooding practices, a corporate buyer 5,000 miles away lacks a reliable way to verify it. Without a rigorous, immutable proof mechanism, the physical climate action has zero financial value on the global market. Measurement, reporting, and verification, MRV, acts as the technological bridge connecting the farm to the financial market. The hardware layer relies on IoT sensors deployed directly into paddies. These capture real-time data, measuring water levels and drying intervals to mathematically prove AWD compliance. Above the fields, a macro-level hardware layer utilizes satellite spectral imagery, sweeping the agricultural zones. This satellite data is used to cross-reference and validate localized IoT sensor data across broad geographical areas. These micro and macro data streams are then compiled into a locked, chronological digital ledger. This immutable telemetry package creates the required audit trail. This audit trail is mandatory to meet the strict cryptographic standards set by international registries like Vera or the gold standard. Through this MRV protocol, raw agricultural telemetry is successfully transformed into a highly valuable, mintable, compliant digital asset. Executing these transactions requires a specific legal architecture, mapping relationships between three entities. The farmer's contractual role is supplying the verifiable climate action data. Mitti Labs operates as the intermediary, providing MRV infrastructure and market access by packaging that data into a carbon credit. This setup introduces ESG arbitrage. Global corporations in the US or EU purchase these verified credits to satisfy internal net zero mandates, pushing a flow of foreign capital into the system. The distribution phase routes this newly injected capital.
Using a direct benefit transfer, or DBT, a significant percentage of the sale goes directly back to the rural farmer. This mechanism creates a new passive income stream for rural agricultural workers. Traditional carbon offset models in decentralized agriculture historically failed because they lacked this transparent distribution. This legal and technological framework bridges physical rural labor directly to Wall Street ESG compliance. Consider the distance between the two ends of the spectrum, the corporate net zero report and the physical reality of the rice paddy. We are witnessing the complete financialization of agricultural telemetry. Sustainability is evolving beyond the scope of traditional corporate social responsibility. It is becoming a discipline defined by engineering, legal drafting, and data verification. As global carbon taxes transition from theory to mandatory regulation, the demand for verified offsets will scale. Platforms capable of cryptographically verifying physical green actions will become the foundational infrastructure of this new asset class. Investors, lawyers, and policy analysts need to closely monitor the agri-carbon market. At the intersection of agricultural tech, legal tech, and finance, verified soil data has become a high-yield asset.
Thank you. Keep learning and growing with Finlex Insight. If you enjoyed the video, don't forget to like, share, and subscribe.